we are going to discuss about the periodic trend of atomic volume. So this we will remember as a curvy property. Now, why curvy? That I will discuss. So let's see the 3D diagram. You can see atomic volume is higher in this side, and as we going from left to right, it is actually flat or zero. And again, if we go more right, it is again increasing. It is again increasing. So the atomic volume, first it is decreasing, then it is almost similar in this range, and then again it is increasing. Now let's see the definition of atomic volume. So the volume occupied by 1 gram of atom of the element in solid state is called the atomic volume. So Lothar Meyer is remembered for atomic volume curve. He made a graph taking 28 elements. That time very less number of elements were known. Later which was modified and all other elements are also plotted. So the definition of atomic volume is simply the definition of volume, right? Atomic volume is atomic weight divided by its density. Now this atomic volume depends on multiple factors. For example, packing efficiency and crystal structure, allotropic forms, temperature. So all these things actually can influence the atomic volume. Now let's see the atomic volume along period. So first we will see it for S and P block elements. This is just for S and P block elements we are observing now. So what happens along period, if we go from left to right, the principal quantum number is fixed because in the same period we have same number of cells in all the elements, right? So the principal quantum number is fixed even if we go from left to right. Now at the beginning, increased effective nuclear charge predominates. So what was happening in the beginning when we go from, let's take this, from lithium to beryllium to boron. So when we go from left to right, the effective nuclear charge is also increasing because we are putting more number of protons, right? So at the first, the effective nuclear charge predominates. So the electropositive elements of the period lies in the descending limb, lower atomic value. So that's why when we are increasing the number of protons from lithium to beryllium to boron, then we can see the effective nuclear charge is more. Because of that, the nucleus is attracting the electrons. I'll draw it again. So as we're putting more and more protons, the girl is becoming more and more attractive. So these lovers, they will try to come close, right? So these faraway lovers or the electrons, they will try to come close and the orbit will shrink. So that's why the volume or space which it is occupying, that is also decreasing. And in case of electropositive elements, so as more and more proton we are putting, the volume is decreasing, again decreasing, again decreasing, again decreasing. Okay. That's why the electropositive elements lie in the descending limb. So these limbs in this graph, these limbs are called the descending limbs. You can see here. These are the descending limbs. The electropositive elements lies in the descending limbs. Now while filling more electrons, now electron-electron repulsion increases. So now if we put more and more electrons, first it was happening that the effective nuclear charge was increasing and the size was shrinking, right? But now if we put more and more electrons, at a time what happens? Now these electrons start to fight. Okay. Now they start to repel each other because they are same charge, negatively charged particle. So they will start fighting and they will try to go away from each other. So now this component is less and this component is more. This electron will try to go away from each other. So because of that, the orbital size will increase. Or you can say this electron-electron repulsion will increase. So the electronegative elements lies in the ascending segment of the curve. So you can see these electronegative segment elements, they are lying in the ascending curves. Here. Now first the effective nuclear charge was dominating, and next is that electron-electron repulsion will dominate. So although size will not increase as much, but actually the atomic volume will start increasing. So this is true for S and P block element. Now next see what happens in case of D block elements. So we are now observing along period for D block elements. So for D block elements, at first atomic volume decreases due to increasing effective nuclear charge. So the same thing, as we increasing the number of protons and electrons from scandium to titanium to vanadium and chromium, we can see the number of protons is increasing. So the electrostatic attraction is increasing, and that's why the size is shrinking and the atomic volume decreases. So then electron-electron repulsion balances the effect of increasing effective nuclear charge. So more or less atomic volume remains constant. Now if you put more and more protons and electrons, if you go from iron to cobalt, nickel, so that time the electrostatic attraction is also increasing. At the same time, electron-electron repulsion is also increasing. So both the factors are actually balancing each other. Means if you see it again, so because of the electrostatic attraction, if it wants to come this side, so because of the electron-electron repulsion, it wants to go in the outer side. And those two magnitudes are almost same. So they actually cancels each other. the effect cancels each other. And at the last, electron-electron repulsion predominates and atomic volume increases for copper and zinc. Sorry, this will be zinc. So at the end of the d block elements, you put more and more electrons and protons. So that time this electron-electron repulsion predominates and the atomic volume increases. So this is the crude way to remember these things. But the main definition is that atomic volume is actually atomic weight divided by density. This thing. So both the factors actually contribute. Now let's see along the group. So what are the factors that are working along the group? So along the group, atomic weight increases. Yeah, so we are putting more and more protons and neutrons in the nucleus, so the atomic weight increases. Now atomic density also increases, which works in the opposite direction. Yeah, so these red ones, I have written the red ones, which are working in the opposite direction, or which are the minor factors, which this is not dominant. The black ones are the dominant factors, okay? Now we have seen that atomic volume is equals to atomic weight divided by density. Now atomic weight is increasing as well as density is also increasing, but the increase of atomic weight is the dominant, that is more. So hence the atomic volume increases along group. So if we see along group, we can see the atomic volume will increase because of the increase in atomic weight. Okay. Now you can see from here also, see this lithium. Then in the group we will have sodium, we will have potassium and rubidium. So these are in a group, and we can see the atomic volume amount is actually increasing. This is a set versus atomic volume curve. So you can see if we increase the atomic number or number of protons, how this behaves. So I'll take this one. Yeah, let's take this potassium, calcium. So when we increase the number of protons, the electrostatic interaction is increasing, so the atomic volume is going down. Same thing is in the d block elements also, scandium, titanium, vanadium. When we increase more and more proton, the electrostatic interaction increases and the atomic volume decreases. Now after that, in case of this iron, cobalt, nickel, we can see this zone. So this zone, in this case, we are putting more and more electrons and protons. So as we are increasing the protons, the atomic attraction or electrostatic attraction is increasing. But at the same time, as we are putting electrons also, the electrostatic repulsion also increases between the electrons of the same shell. So both the factors balances out each other, and that's why we have almost same kind of atomic volume. Now when we put more and more protons and electrons, so that time the electron-electron repulsion that increases, and because of that we get increase in the atomic volume. Same thing happened in the p block elements also. As we put more and more electrons, the atomic volume will increase because of the electron-electron repulsion. Fine. So till now, what we have seen? We have seen that atomic volume is actually a curvy property. So it first decreases and then increases. So along a period, atomic volume first decreases due to the increasing effect. Just let me take this laser pointer. Yeah. So along a period, atomic volume first decreases due to the increasing effective nuclear charge. Then the electron-electron repulsion starts to increase and atomic volume also increases. Along a group, atomic volume increases due to the increase in atomic weight. Alkali metal ions having highest atomic volume occupies the peaks of the graph. So if you see this graph, so the peaks are occupied by the alkali metal ions here. All these are alkali metal ions which are occupying the peaks. With the increase of atomic number, the electropositive elements lie on the descending limb, whereas the electronegative elements lie on the ascending limbs. For the transition metals, the atomic volume remains almost same along the period, and they occupy the flat region at the bottom. Whereas in the case of lanthanides and actinides, they occupy the descending limbs near the bottom because of the lanthanide and actinide contraction. So this lanthanide and actinide contraction I have explained in the previous lecture. So these are some keynotes that you need to remember for the case of atomic volume or the periodic trend of atomic volume.
Hey genius, I hope you liked the video and the concepts are clear. So if you want to know more and if you want to learn more, you can go and check the periodic table and periodic trends folder. I have already uploaded 7 lectures on this topic. Please go and watch all those 7 lectures. I hope it will be very useful for you. And if you think these videos are knowledgeable, please share it with your friends and don't forget to subscribe. Okay? Thank you. Bye bye.